The canyon's so vast it shouldn't exist. Mars is hiding something. Not aliens, not cities, not secret machines buried beneath the dust. Something far stranger, a wound. A scar so enormous that if it were carved across Earth, it would stretch from New York to Los Angeles, swallow entire mountain ranges, and dominate the face of our planet so completely that civilization would organize itself around it. And yet most people have never truly seen it. When you picture Mars, you probably imagine a barren red desert, endless sand, empty horizons, a cold, dead world. That picture is wrong. Mars is not a simple desert. Mars is a graveyard of impossible landscapes, a world where volcanoes tower 3 times higher than Everest, where dust storms can engulf an entire planet, where ancient rivers once flowed through valleys larger than many countries, and nowhere is that hidden reality more shocking than the first place on this journey. A place called Valles Marineris, the largest canyon system known anywhere in the solar system. When scientists first began mapping Mars in detail during the 1970s, images returned by NASA's Mariner 9 spacecraft revealed something nobody expected: a gigantic crack stretching across the Martian surface. At first it looked like a photographic artifact, a mistake, a shadow. It wasn't. The feature was real, and it was monstrous. Valles Marineris extends roughly 4,000 kilometers across Mars. That is about 1/4 of the entire circumference of the planet. Its width reaches over 200 kilometers in some places. Its depth plunges as much as 7 kilometers below the surrounding terrain. For comparison, Earth's Grand Canyon is approximately 446 kilometers long and about 1.8 kilometers deep at its deepest point. Place the Grand Canyon inside Valles Marineris and it begins to look like a scratch inside a crater. You are not looking at a canyon. You are looking at a planetary wound. Standing at its edge would be unlike anything a human being has ever experienced. Imagine standing on a cliff. You look across, but there is no opposite side. The horizon simply vanishes into distance. The canyon becomes so wide that the far wall often disappears beyond the curve of the planet itself. Your brain would struggle to comprehend what your eyes are seeing. Human beings evolved in environments measured in meters and kilometers. Valles Marineris is measured in geological absurdities. But the size isn't the most fascinating part. The mystery is how it formed. On Earth, giant canyons are usually carved by rivers. Water acts like a slow-motion knife, cutting through rock over millions of years. Mars appears to have taken a different approach. Scientists believe Valles Marineris was created primarily by tectonic forces. The crust itself fractured, the ground stretched apart, entire sections collapsed downward. Imagine grabbing a loaf of bread from both ends and pulling until the center tears open. Scale that process to planetary dimensions. That may be what happened here. The culprit may have been another Martian giant. Olympus Mons, the largest volcano in the solar system. As the immense volcanic region known as Tharsis grew over hundreds of millions of years, its unimaginable weight may have stressed the crust of Mars. The surface cracked, the fractures widened, the canyon was born, and then water arrived. A long time ago, Mars was not the frozen desert we see today. Ancient Mars possessed rivers, lakes, possibly even oceans. Water surged through portions of Valles Marineris as deepening sections and sculpting terrain that still puzzles scientists today. The evidence is everywhere: ancient channels, sedimentary deposits, minerals that form in the presence of liquid water, ghosts of a wetter world. When orbiters study the canyon walls, they find layers. Thousands upon thousands of layers, each one a page from a history book written billions of years ago. Every cliff face preserves information about climates, floods, volcanic eruptions, dust storms, and planetary changes stretching back to the dawn of Mars itself. In some regions, strange landslides have left behind deposits hundreds of kilometers long. Entire mountains collapsed, not pieces of mountains, mountains. The resulting debris fields are so enormous they resemble frozen oceans of broken stone. And then there are the caves. Mars is famous for mysterious pits and skylights. Many appear throughout the canyon system. Some may lead into vast underground chambers. Places protected from cosmic radiation, protected from temperature extremes, protected from the lethal environment that dominates the Martian surface. If humans ever establish permanent settlements on Mars, caves inside Valles Marineris may become some of the safest locations on the planet. Because Mars is not merely cold, It is hostile. The atmosphere is less than 1% as dense as Earth's. Average temperatures hover around minus 63 degrees Celsius. Radiation constantly bombards the surface. A human standing unprotected on Mars would die quickly. The planet does not welcome visitors. It tolerates them. Barely. Yet paradoxically, this terrifying canyon may someday shelter human explorers, a wound becoming a refuge, a scar becoming a home. There is another reason scientists are fascinated by Valles Marineris. Some of the strongest evidence for ancient habitability may exist here. Life requires certain ingredients: water, energy, time. The canyon appears to have possessed all three. Billions of years ago, water flowed through its depths. Chemical reactions occurred within its rocks. Underground environments may have remained stable for extraordinary periods. If Mars ever hosted microbial life, traces could still be preserved inside protected deposits hidden within the canyon walls. That possibility changes everything, because finding life on Mars would not merely answer a scientific question. It would answer a philosophical one. Are we alone, or is life something the universe creates whenever conditions allow? The answer may be buried somewhere beneath these cliffs. The mountain that should be impossible. Mars has a monster, not a creature, not a machine, a mountain so large that if you stood on its summit, you would not realize you were standing on a mountain at all. The slopes are too vast. The scale is too immense. The human brain simply wasn't built to understand something this big. Its name is Olympus Mons, and it should not exist. Everything you know about mountains tells you that Olympus Mons is impossible. On Earth, mountains have limits. Gravity imposes rules. Rock can only stack so high before it collapses under its own weight. Tectonic plates constantly move, crumpling, grinding, and reshaping landscapes. Even the mightiest peaks eventually erode. Wind attacks them. Rain dissolves them. Ice fractures them. Time destroys them. Mars plays by different rules, and because of those rules, Olympus Mons became something no world should be allowed to build. The largest volcano in the solar system, by a staggering margin. Its summit rises approximately 22 kilometers above the surrounding plains. Mount Everest, measured from sea level, reaches about 8.8 kilometers. Olympus Mons is more than twice as tall. But that comparison doesn't fully capture the insanity. Imagine taking Mount Everest, then placing another Everest on top of it, then adding a little extra. That's the scale we're talking about. Yet height alone is misleading. Olympus Mons is also enormous horizontally. Its base stretches roughly 600 kilometers across. That is comparable to the distance between major cities on Earth. From ground level, a person standing near its base would see something strange. Nothing. No dramatic peak. No towering cone. No giant mountain dominating the horizon. The curvature of Mars would hide most of it. You could spend hours driving toward Olympus Mons and barely perceive its rise. It is less like climbing a mountain and more like ascending an entire continent. The volcano occupies so much territory that it creates its own weather patterns. Clouds form around it. Atmospheric currents interact with it. Even from orbit, it dominates the Martian landscape like a king among ruins. How did such a thing happen? The answer begins with the death of Mars. Earth remains geologically alive. Its crust is broken into massive tectonic plates that drift slowly across the planet. Volcanoes form over hotspots. The plates move. The volcanoes move away from their magma sources. New volcanoes emerge elsewhere. This process prevents a single volcano from growing forever. The Hawaiian Islands demonstrate the principle perfectly. A hotspot remains fixed. The Pacific Plate moves overhead. One volcano forms, then another, then another. A chain appears. Mars lacks this system. The planet's crust appears to be mostly stationary. When a hotspot formed beneath the surface billions of years ago, it stayed in one place. Magma continued rising again and again and again for unimaginable lengths of time. Each eruption added another layer, another flow, another blanket of lava. The mountain kept growing. No moving tectonic plates carried it away. Nothing interrupted the process. Olympus Mons became a geological machine that never stopped feeding itself. Millions of years became tens of millions. Tens became hundreds. Eventually, the volcano reached dimensions that seem almost fictional. Its summit caldera alone measures roughly 80 kilometers across. The caldera is the collapsed region at the top left behind after enormous volcanic eruptions empty underground magma chambers. Most volcanoes possess a single caldera. Olympus Mons contains multiple overlapping calderas, a stack of gigantic collapse pits created during different eras of activity. Each one would qualify as a major geological landmark on Earth. Here they exist as mere details atop a planetary giant. The volcano's flanks preserve evidence of lava flows extending hundreds of kilometers. Entire regions were repeatedly buried beneath molten rock. Imagine watching rivers of fire advancing across landscapes for centuries. Not days, not weeks, centuries. That may be closer to what ancient Mars experienced. And then there is the cliff, one of the strangest features on the mountain. Around much of Olympus Mons runs a dramatic escarpment, a cliff reaching up to 8 kilometers high in places. This means portions of the volcano rise from the surrounding terrain like an enormous fortress wall. Scientists still debate exactly how this formed. Some evidence suggests gigantic landslides may have occurred. Other theories involve interactions between lava and ancient water or ice. Whatever the cause, the result is astonishing. The largest volcano in the solar system is surrounded by one of the largest cliffs in the solar system. Everything about Olympus Mons seems excessive. Everything about it seems designed to challenge human intuition. If you somehow stood atop its summit, the experience would be surreal. Mars already has a lower gravity than Earth, only about 38% of Earth's gravitational pull. You would weigh less, jump higher, move differently. The sky would appear butterscotch and dusty. The atmosphere would be incredibly thin. The horizon would stretch far into the distance, and beneath you would lie a landscape shaped by billions of years of volcanic history. No birds, no wind in the earthly sense, no sound beyond what your suit transmitted, just silence. A silence so complete it might feel supernatural. Because Olympus Mons exists in a world where almost nothing lives. It rises above a planet that lost most of its atmosphere long ago, a world where rivers vanished, oceans disappeared, habitability faded. The mountains survived all of it. It watched Mars change from a warmer planet into a frozen desert. It endured cataclysmic climate shifts, global dust storms, meteor impacts, billions of years of cosmic punishment. And it remains standing. Scientists believe some volcanic activity on Mars may have continued surprisingly recently in geological terms, possibly within the last few million years. That sounds ancient, but for a planet over 4.5 billion years old, it is remarkably recent. There remains a tantalizing possibility. Olympus Mons may not be entirely dead, not active in the dramatic sense we associate with erupting volcanoes, but perhaps not completely extinct either. Deep beneath the surface, residual heat may still linger. Ancient geological processes may not have entirely ended. Mars occasionally reminds us that it still possesses mysteries, and Olympus Mons sits at the center of many of them. What makes this place especially haunting is the realization that no human has ever looked at it directly. Every image you've seen came from orbiters, satellites, robotic observers. No astronaut has stood inside the caldera. No explorer has watched dawn break across its slopes. No human footprints mark its volcanic dust. For now, Olympus Mons remains hidden from human eyes, known, mapped, photographed, but never truly witnessed. A mountain larger than imagination, a monument to a planet's lost power, and a reminder that Mars is not merely another world, it is a world of extremes, a place where nature abandoned restraint, and Olympus Mons is only one of its masterpieces. The frozen waterfall of the Martian underworld. Mars remembers water, not rivers flowing beneath blue skies, not waves crashing against coastlines, not rain falling from clouds. Those days are long gone, but scattered across the planet are places where the memory of water remains trapped in stone, places that look as though time itself suddenly stopped. One of the strangest is hidden inside a vast impact basin called Hebe's Chasma, a place so bizarre that scientists spent years debating how it could possibly exist. At first glance, it resembles a giant island, but not an island surrounded by water, an island surrounded by emptiness. A colossal mountain rising from the floor of a canyon, steep cliffs, layered walls, strange terraces, a landscape that appears almost artificial when viewed from orbit. If Valles Marineris is Mars's greatest wound, Hebe's Chasma is one of the deepest mysteries hidden inside that wound. The canyon containing it measures roughly 315 kilometers across. The surrounding walls tower thousands of meters above the basin floor, and in the center sits a gigantic mesa-like mountain, isolated from everything around it. The feature looks wrong. as though a piece of terrain was dropped into the canyon by some impossible force. Yet nature created it. The question is how? Scientists have proposed multiple explanations. Some suggest sediments slowly accumulated inside an ancient lake. Others believe volcanic ash repeatedly settled here over immense spans of time. Some theories combine both processes, layer upon layer, century after century, million year after million year. The deposits grew upward until they formed a mountain inside the canyon itself. What makes the structure extraordinary is its internal layering. Thousands of distinct layers stack upon one another, like pages inside a planetary archive. If you could cut through the mountain and read every layer, you might reconstruct enormous portions of Martian history. Ancient climates, dust cycles, volcanic eruptions, water activity, everything recorded in stone. The mountain becomes less of a geological formation and more of a library older than complex life on Earth. But the truly remarkable discovery came when orbiters began studying the minerals hidden within these layers. They found sulfates, large quantities of them. On Earth, sulfates commonly form when water evaporates. Imagine a shallow lake slowly drying beneath the sun. The water disappears. Minerals remain. The same process may have occurred here billions of years ago. If true, Hebe's Chasma may preserve evidence of ancient lakes that once occupied parts of Mars. Not brief puddles, not temporary trickles, persistent bodies of water, places where chemistry had time to work, places where life, if it ever emerged on Mars, might have found an opportunity. This is one reason planetary scientists find locations like Hebe's Chasma so compelling. Water changes everything. The search for life is ultimately a search for environments where water once existed. Because everywhere life exists on Earth, water is involved. Inside volcanoes, beneath Antarctic ice, at the bottom of the ocean, inside rocks kilometers underground. Life follows water with almost obsessive consistency, and Mars appears to have possessed far more water than many people realize. Ancient river valleys stretch across the planet. Deltas remain preserved. Minerals reveal long periods of interaction between rock and liquid water. Some regions may have supported lakes for thousands or even millions of years. Hebe's Chasma may be one of those regions, but there is another reason this place fascinates researchers. Its appearance resembles something almost impossible, a frozen waterfall. Imagine water cascading downward. Then imagine time stopping forever. The labyrinth that could swallow a nation. Mars contains a maze. Not a simple maze, not a network of twisting valleys, a true labyrinth. A landscape so chaotic, so broken, and so bewilderingly complex that from orbit it appears as though an entire section of the planet was shattered by some unimaginable force. Its name is Noctis Labyrinthus, the labyrinth of the night, and few places in the solar system deserve their name more. If you were dropped into this region without a map, survival would become almost impossible. Towering cliffs would surround you. Gigantic chasms would cut across the landscape. Dead ends would appear everywhere. Massive fractures would split the ground beneath your feet. Every direction would look wrong. Every horizon would feel trapped. The terrain resembles the ruins of a civilization built by geology itself. And unlike many places on Mars, scientists still struggle to fully explain how this labyrinth formed. That uncertainty makes it one of the most fascinating locations on the planet. To understand Noctis Labyrinthus, you first need to understand something important about Mars. The planet was not always geologically quiet. Billions of years ago, enormous forces were at work beneath its surface. The greatest of these forces emerged in the Tharsis region, a colossal volcanic province dominated by giant volcanoes, including Olympus Mons. As Tharsis grew, its incredible weight stressed the surrounding crust. Imagine placing a mountain range on a sheet of glass. Eventually, cracks would spread outward. The Martian crust behaved in a similar way. Tension built, the ground stretched, fractures appeared, and some of those fractures eventually evolved into Noctis Labyrinthus. The scale is difficult to comprehend. The labyrinth extends for more than 1,200 kilometers. Individual canyons plunge several kilometers deep. Some walls rise nearly as high as major mountain ranges on Earth. The region consists of intersecting valleys, collapsed blocks, fault systems, and giant troughs arranged in a pattern so complex that it resembles cracked pottery viewed from orbit. Scientists believe portions of the terrain collapsed after underground material was removed. Perhaps magma chambers emptied, perhaps water escaped, perhaps both. Entire sections of crust simply gave way. The ground sank, gigantic voids opened, the labyrinth expanded. Imagine an underground city suddenly losing all support beneath it. Buildings collapse, roads fracture, the landscape breaks apart. Now scale that process to hundreds of kilometers. That begins to approach what happened here. But there is another possibility that excites researchers even more. Water. Again and again, Mars leads us back to water. Ancient water may have played a critical role in shaping portions of Noctis labyrinthus. Minerals discovered throughout the region suggest long-term interaction with liquid water. Clay deposits, hydrated minerals, chemical signatures that point toward a wetter past. Some studies indicate that groundwater may once have circulated through parts of the labyrinth. If true, then beneath this broken landscape may have existed one of the most potentially habitable environments on ancient Mars. That matters because underground environments are special. Even on modern Mars, conditions beneath the surface are less hostile than conditions above it. The surface suffers constant radiation bombardment. Temperatures swing wildly. The atmosphere offers almost no protection. Underground, things change. Rock shields against radiation. Temperatures stabilize. Water can persist longer. On Earth, underground ecosystems thrive in places completely isolated from sunlight. Microbes live deep within rock formations. They survive using chemistry rather than photosynthesis. Life finds a way. That realization has changed how scientists think about Mars. Instead of searching only for ancient lakes and rivers, researchers increasingly investigate subsurface environments, places where life could have endured long after the surface became uninhabitable. And Noctis labyrinthus may preserve evidence of exactly those kinds of environments. Some researchers even describe portions of the region as one of the most promising locations for future exploration. Not because it is easy, quite the opposite, because it is difficult, because its complexity suggests a long geological history, because its fractures may expose layers otherwise hidden deep underground. Imagine reading a book where every page has been ripped apart and scattered across a room. At first, it looks like chaos, but within that chaos lies information. That is Noctis labyrinthus, a shattered archive, a broken history book, a place where the planet accidentally revealed its secrets. The visual appearance alone is astonishing. Under sunlight, the canyon walls cast immense shadows. Darkness pools inside fractures. Cliffs rise abruptly from the valley floor. Entire mesas stand isolated between deep troughs. The terrain feels alien even by Martian standards. Many locations on Mars resemble deserts. Noctis labyrinthus resembles the aftermath of a planetary catastrophe, and perhaps that impression is not entirely wrong, because in many ways, Mars is a planet defined by catastrophes. Its magnetic field disappeared billions of years ago. Without that protective shield, the solar wind slowly stripped away much of the atmosphere. As atmospheric pressure declined, liquid water became increasingly unstable. Rivers vanished, lakes evaporated, the planet transformed. Mars became colder, drier, more hostile. What we see today may be the surviving skeleton of a once more active world, and places like Noctis labyrinthus expose that skeleton with unusual clarity. Standing here would feel deeply unsettling. The immense cliffs would block portions of the sky. The valleys would stretch endlessly into shadow. Distances would become difficult to judge. The sheer size of the fractures would challenge perception itself. You might feel less like an explorer and more like an ant wandering through the cracks of a broken continent. Yet there would also be beauty, austere beauty, ancient beauty, the kind of beauty found in places utterly indifferent to human existence. Mars does not care whether anyone visits. The labyrinth existed for hundreds of millions of years before humanity evolved. It will likely remain long after our civilization disappears. That realization is humbling. Every human achievement, every empire, every language, every war, every triumph, all of it occupies a tiny sliver of time compared to the age of these cliffs. The flood channel that should not exist. Mars was once struck by a catastrophe so immense that if it happened on Earth today, it would rewrite human history in a matter of days. Entire continents would drown, coastlines would vanish, cities would disappear beneath walls of water, civilization itself might not survive. The evidence for that ancient catastrophe still scars the Martian surface. A place called Valles. one of the largest flood channels ever discovered in the solar system, and it should not exist, because Valles tells a story that sounds impossible, a story of water unleashed on a planetary scale. For generations, Mars was imagined as a dry world, a dusty desert that had always been lifeless and barren. That illusion began to collapse as spacecraft started mapping the planet in detail. Researchers noticed enormous channels winding across the landscape. Not river valleys, something far bigger, far more violent. Features so gigantic that ordinary rivers could never explain them. Valles became one of the strongest pieces of evidence that Mars once experienced floods of unimaginable power. The system stretches for approximately 3,000 kilometers, longer than many major nations. Its width reaches hundreds of kilometers. Entire mountain ranges could fit inside parts of it. From orbit, the landscape resembles the aftermath of some ancient planetary wound. The terrain has been stripped bare, scoured clean, carved by forces almost beyond comprehension. Scientists believe the channel formed when colossal quantities of water suddenly erupted onto the surface. Not gentle streams, not seasonal rivers, cataclysmic floods, the kind of floods that transform geography itself. To understand the scale, imagine every major river on Earth: the Amazon, the Nile, the Mississippi, the Yangtze. Now imagine them all flowing simultaneously through a single channel. Then multiply that flow many times over. Even that comparison may still underestimate the event. Some models suggest peak discharges may have exceeded anything Earth's modern rivers have ever produced. The water moved like a planetary weapon. Everything in its path was reshaped. Entire landscapes vanished beneath the torrent. Rock formations were torn apart. Sediments were transported across enormous distances. The flood left behind islands, terraces, streamlined hills, and giant erosional scars still visible billions of years later. The question is simple: where did all that water come from? And the answer may be hidden beneath the surface. Ancient Mars appears to have stored enormous quantities of water underground. Much of it may have existed as ice trapped beneath layers of rock and sediment. Then something happened. Volcanic activity, tectonic stresses, impacts, perhaps a combination of all three. Whatever the trigger, underground reservoirs may have suddenly ruptured. Water exploded upward, the surface collapsed, the flood began. Imagine puncturing a pressurized reservoir the size of a country. Now imagine gravity taking over. The result would be terrifying. For a brief period in Martian history, entire regions may have been transformed into raging inland seas. The water rushed downhill across vast distances, excavating channels that remain visible today. Valles became one of the greatest of those channels, a monument to planetary violence. Yet despite its destructive origins, the flood channel also tells a hopeful story, because wherever water exists, the possibility of life follows close behind. Before the catastrophe, underground reservoirs may have remained stable for immense periods of time, protected from radiation, shielded from harsh surface conditions. These environments may have provided exactly the kind of habitat microbial organisms require. On Earth, similar environments teem with life. Microbes inhabit deep aquifers kilometers beneath the surface. Some survive entirely without sunlight. They feed on chemical energy stored within rocks. Entire ecosystems flourish in darkness. If Mars ever hosted life, underground reservoirs may have been among its safest refuges. And when those reservoirs burst open, traces of that ancient environment may have been transported across the landscape. That possibility fascinates astrobiologists. Flood channels like Valles may have scattered evidence of ancient habitability over enormous areas. Every exposed layer becomes a potential clue. Every mineral deposit becomes a possible record. Every rock becomes a witness. The landscape itself serves as evidence. Gigantic streamlined islands sit within the channel. These formations resemble features created by catastrophic floods on Earth. During the last ice age, parts of North America experienced enormous megafloods when glacial lakes suddenly burst. The resulting floods carved landscapes still visible today. Those floods were extraordinary by terrestrial standards. The Martian versions were even larger, much larger. Nature performed the same experiment on two worlds. Mars simply turned the scale knob far higher. Standing inside Valles would be a deeply strange experience. The channel is so vast that much of its shape would be invisible from ground level. You would see cliffs rising in the distance, broad plains stretching toward the horizon, ancient islands of rock standing isolated amid the terrain. Yet the full structure would remain hidden. Only from orbit does the true magnitude become apparent. This is one of the recurring themes of Mars. Many of its greatest wonders exceed the scale humans naturally understand. Our instincts evolved in forests, grasslands, and coastlines. Mars presents landscapes measured in hundreds and thousands of kilometers. The brain struggles to process them. What makes Casey Valles especially haunting is its silence. Every flood leaves sound behind. Earth's rivers roar. Waterfalls thunder. Storm surges crash. Floods scream across the landscape. Casey Valles preserves the aftermath after the sound has died. The water vanished billions of years ago. The violence ended. Only the scar remains. It is like discovering an ancient battlefield after everyone has gone home. The evidence remains. The city of stone that looks impossible. There is a place on Mars that should not exist. A place that has fueled speculation, conspiracy theories, internet myths, and wild imaginations for decades. A place where shadows and stone combine to create one of the strangest landscapes ever photographed on another world. At first glance, it looks artificial, almost engineered. Rows of towering formations rise from the surface. Angular shapes cast long shadows across the desert. From certain viewing angles, the landscape resembles the ruins of a forgotten city. A city abandoned billions of years ago. A city erased by time. Of course, it isn't a city, but understanding why it looks like one reveals something even more fascinating. This place is part of a region known as the Medusae Fossae Formation, one of the most mysterious geological structures on Mars and one of the least understood. Stretching across an area larger than India, the Medusae Fossae Formation occupies an enormous portion of the Martian equatorial region. Its deposits cover hundreds of thousands of square kilometers. Its layers reach thicknesses of several kilometers. Yet despite decades of study, scientists still debate exactly how it formed. That uncertainty makes it one of the most intriguing locations on the entire planet. When spacecraft first began returning detailed images, researchers noticed strange landscapes unlike anything seen elsewhere on Mars. Wind had sculpted parts of the formation into bizarre shapes: tall ridges, narrow towers, long parallel walls, curving structures resembling fortifications. The terrain looked less like geology and more like architecture. Under low-angle sunlight, the illusion became even stronger. Shadows transformed ordinary rock formations into what appeared to be streets, buildings, and colossal ruins. Human beings are pattern recognition machines. Our brains evolved to identify faces, structures, and familiar shapes. Sometimes we identify them even when they aren't really there. This phenomenon is called pareidolia. It explains why people see faces in clouds, animals in rock formations, and familiar shapes on distant worlds. Mars is particularly good at triggering it. The famous face on Mars became one of the most famous examples. Early low-resolution images made a natural mesa resemble a giant human face. Years later, higher-resolution photography revealed the truth. An ordinary geological formation. The mystery vanished. Yet the Medusae Fossae Formation remains different. Even when viewed with modern instruments, its landscapes still appear remarkably artificial, not because they are artificial, but because nature sometimes creates shapes that seem impossible. The real explanation may be far more extraordinary than any alien civilization. Many researchers believe the formation consists largely of volcanic deposits. Ancient eruptions may have blasted enormous quantities of ash into the atmosphere. Layer after layer accumulated across vast regions. Over time, the deposits hardened. Then Mars began sculpting them. Wind became the artist. For billions of years, Martian winds carved the soft material. Tiny particles of dust acted like sandpaper, millimeter by millimeter, meter by meter. The landscape transformed. Weak material disappeared. Harder material remained. Towers emerged. Walls formed, labyrinths developed. Nature spent billions of years creating a sculpture garden on a planetary scale. The result is breathtaking. Some ridges extend for tens of kilometers. Certain formations rise hundreds of meters above the surrounding terrain. Entire regions resemble ruined castles, cathedrals, and ancient fortresses. The landscape feels less like a desert and more like the remains of some forgotten civilization. But the mysteries go deeper. Radar observations have revealed something surprising. The Medusae Fossae Formation may contain enormous quantities of water ice, far more than researchers once suspected. In 2024, scientists analyzing radar data suggested that parts of the formation could contain ice deposits several kilometers thick beneath layers of dust and sediment. If confirmed, the total volume of water would be staggering, enough to cover the entire planet in a shallow ocean. Not deep, but global. That possibility changes how scientists view the region. What once appeared to be merely a geological curiosity may actually be one of the largest water reservoirs on Mars. And water means opportunity. Future explorers may someday depend upon locations like this. Water provides drinking supplies, oxygen production, rocket fuel manufacturing, life support. A settlement cannot survive without it. In a strange twist of fate, one of Mars' most mysterious landscapes may eventually become one of humanity's most valuable resources. Imagine standing there, towering formations surrounding you, dust drifting across the ground, the thin atmosphere glowing beneath a pale sun, the landscape stretching outward like the ruins of a lost empire. You know it is natural. You understand the geology. Yet part of your brain still whispers another possibility. The illusion persists. That is the power of this place. It feels haunted, not by ghosts, by perception itself. Mars repeatedly confronts us with a difficult truth. The universe is under no obligation to look familiar. Nature can create landscapes that resemble engineering. It can carve structures that appear designed. It can produce beauty so strange that human intuition struggles to accept it. The Medusae Fossae Formation is one of the greatest examples, a place where geology masquerades as architecture, a place where billions of years of erosion created something that looks almost intentional. And perhaps that is what makes it so profound, because it reminds us that the universe does not need intelligence to create wonder. Sometimes physics is enough, sometimes time is enough, sometimes wind blowing across a dead world for billions of years is enough. The resulting landscape becomes indistinguishable from fantasy. Yet beneath the mystery lies another lesson. Mars is not merely a collection of rocks. It is a record of planetary evolution. Every cliff, every ridge, every deposit tells a story of volcanoes, atmosphere, water, ice, and time. The Medusae Fossae Formation preserves one chapter of that story, a chapter written by ash and wind, a chapter so strange it still challenges scientific understanding. And hidden beyond its sculpted towers lies something even more extraordinary, a place where an entire sea may have once existed, a shoreline stretching across a world that is now dry, a ghost ocean waiting to be rediscovered. The shoreline of a lost ocean. Mars may have once possessed an ocean, not a lake, not a temporary floodplain, an actual ocean, a body of water so immense that it could have covered nearly a third of the planet. If that sounds impossible, consider this. Nearly every major discovery made on Mars over the past few decades has pushed scientists toward the same conclusion. Ancient rivers flowed, ancient lakes existed, groundwater circulated, glaciers formed, floods erupted. Again and again, the evidence points toward a wetter world. Eventually, a question becomes unavoidable. Where did all that water go? And more importantly, where did it come from? One of the most compelling answers lies in a region called Arabia Terra and the vast northern lowlands beyond it, a place where some scientists believe humanity has already found the shoreline of a vanished sea. If they are correct, then Mars once looked radically different from the world we know today. The image most people carry in their minds is wrong. Instead of endless red deserts, parts of ancient Mars may have resembled a cold coastal world. Vast bodies of water stretching toward distant horizons, river systems feeding into inland seas, sediments accumulating along beaches, waves rolling beneath a pink sky. Not Earth, but something far closer to Earth than modern Mars. The idea first gained momentum when researchers began noticing strange features along the boundary between the northern plains and the southern highlands. Certain formations resembled coastlines. Others resembled deltas. Still others appeared strikingly similar to sediment deposits found along ancient shorelines on Earth. At first, many scientists remained skeptical. Extraordinary claims require extraordinary evidence, and claiming that an entire ocean once existed on Mars certainly qualifies as extraordinary. Yet the evidence continued growing. Orbiters detected minerals associated with long-term water activity, Valley networks converge toward the northern plains. Sediment deposits accumulated in patterns difficult to explain without large standing bodies of water. The pieces slowly began fitting together. Imagine Mars 4 billion years ago. The atmosphere is thicker. Temperatures are somewhat warmer. Liquid water can remain stable on the surface. Rivers carve valleys through ancient terrain. Rain may occasionally fall. Groundwater circulates beneath the crust, and in the northern hemisphere lies a gigantic ocean. Scientists sometimes refer to this hypothetical ocean as Oceanus Borealis, the Northern Ocean. Its exact size remains debated. Its exact depth remains uncertain. But some estimates suggest it could have contained volumes of water comparable to Earth's Arctic Ocean. If true, the implications are staggering. An ocean changes everything. Oceans regulate climate, they transport heat, they drive weather systems, they create chemical environments favorable for life. On Earth, life emerged in a world dominated by water. Every ocean becomes a laboratory where chemistry experiments continuously for millions of years. The ingredients mix, energy flows, complexity increases. Life eventually appears. At least it did here. Could the same thing have happened on Mars? That question drives much of modern planetary science, because an ancient ocean would dramatically increase the chances that life once emerged there. Not intelligent life, not civilizations, not cities hidden beneath the sand. Microbial life, tiny organisms inhabiting shallow coastal waters, sediments, or hydrothermal environments. Life simple enough to survive, life simple enough to leave traces behind, life that may still be detectable billions of years later. If such evidence exists, ancient shorelines would be among the best places to search. Shorelines are geological treasure chests. They preserve sediments, organic material, chemical signatures, environmental records. On Earth, ancient coastlines reveal enormous amounts about past climates and ecosystems. Martian shorelines may preserve similar clues. But there is a problem. Mars is old, very old. Over billions of years, impacts, volcanic activity, erosion, dust accumulation, and tectonic processes altered the landscape. The evidence is fragmented, broken, incomplete. Researchers are trying to reconstruct an ancient coastline from pieces scattered across a planet. It is like attempting to rebuild an entire civilization from a handful of weathered stones. The task is difficult, yet the clues remain tantalizing. Some regions display giant wave-like deposits. Others contain sedimentary features consistent with coastal environments. Certain elevations seem to correspond with possible ancient sea levels. None of these observations individually prove the existence of an ocean. Together, they paint a compelling picture, and the picture keeps getting stronger. Standing on one of those ancient shorelines would be an emotional experience, not because of what you see, because of what you don't see. The ocean is gone, the waves are gone, the coastline is silent, only the skeleton remains. Imagine standing on a beach where the sea vanished billions of years ago. You can still see the shape of the shore, you can still recognize the terrain, but the water itself has disappeared into history. That is what much of Mars feels like. A world filled with absences, absent rivers, absent oceans, absent atmospheres, absent possibilities. Everywhere you look, the planet hints at something that used to exist, something lost, something taken away. And perhaps that is why Mars fascinates us so deeply. It is not merely another planet, it is a warning, a reminder that worlds can change, that habitability is not permanent, that even entire oceans can vanish. Earth often feels eternal. The oceans seem permanent. The atmosphere seems stable. The climate feels reliable. Mars reminds us otherwise. Planetary conditions can transform. Magnetic fields can disappear. Atmospheres can erode. Water can escape into space. Entire worlds can become unrecognizable. The shoreline of a lost ocean is therefore more than a geological feature. It is a monument to impermanence, a reminder that planets evolve. Some thrive, some die. Mars may have experienced both, and if an ocean truly existed here, Then somewhere beneath the sediments, somewhere beneath the dust, somewhere beneath billions of years of history, the glacier of stone frozen in time. There is a place on Mars where the ground appears to flow. Not water, not lava, the ground itself. From orbit, enormous rivers seem to wind across the landscape. They twist around obstacles, they spill into valleys, they spread across plains. At first glance, they look exactly like ancient lava flows. But something about them is wrong. The shapes are too smooth, too broad, too unusual. And when scientists studied them more closely, they discovered something astonishing. These may be some of the largest glaciers ever identified beyond Earth. A frozen world hidden beneath a blanket of dust, a landscape where ice masquerades as stone. One of the most spectacular examples exists in a region known as Valles Marineris, a place that feels less like Mars and more like the remains of a forgotten ice age. To understand why this region is so extraordinary, you must first understand a strange fact about Mars. The planet does not always keep its ice at the poles. Earth's rotation is relatively stable. Our planet wobbles slightly over time, but the changes remain modest. Mars is different, much different. Because Mars lacks a large stabilizing moon like Earth's, its rotational tilt can change dramatically over millions of years. Sometimes the poles point more directly toward the sun, sometimes less. The shifts can be extreme. As the planet's tilt changes, so does its climate. Ice migrates, snowfall patterns change. Entire regions experience dramatic environmental transformations. During certain periods of Martian history, ice that normally remained trapped at the poles may have spread toward lower latitudes. Glaciers formed, massive glaciers, glaciers stretching across landscapes that today appear completely barren. Then, the climate changed again. The ice retreated, but not entirely. Something remarkable happened. Dust accumulated on top. A protective blanket formed. The surface began looking like ordinary terrain. Yet beneath that dusty armor, enormous quantities of ice remained. The glaciers became hidden, fossilized, frozen in place, like giant prehistoric creatures trapped beneath the soil. Valles Marineris contains some of the best evidence for this process. The region sits between Mars's southern highlands and northern lowlands, a transitional zone filled with mesas, valleys, cliffs, and strange flowing landforms. Many of these formations resemble glaciers so strongly that planetary geologists immediately recognized the similarities. The shapes were familiar, the behavior was familiar, only the setting was alien. Radar instruments later confirmed the suspicion. Large amounts of ice existed beneath the surface. Not traces, not isolated pockets, entire glaciers. In some places, the ice may be hundreds of meters thick. Imagine standing on what appears to be a rocky plain. Dust beneath your boots, cliffs rising in the distance, a frozen desert stretching toward the horizon. Yet hidden beneath that surface lies a glacier older than human civilization by thousands of times. A glacier that may have remained preserved for millions of years. The idea feels almost impossible. But Mars repeatedly reminds us that appearances are deceptive. What looks dead often hides complexity. What looks empty often conceals history. These buried glaciers are among the most important discoveries in Martian science, not simply because they reveal climate history, because they reveal resources. Future explorers will need water, large amounts of it. Every settlement, every habitat, every greenhouse, every rocket, everything depends on water. Transporting water from Earth would be enormously expensive. Finding local supplies changes everything. The glaciers of Valles Marineris may someday become lifelines for human explorers. Water for drinking, water for agriculture, water for oxygen production, water for fuel manufacturing. The hidden ice may transform this remote wilderness into one of the most valuable locations on the planet. Yet the scientific significance extends even further. Ice is a time capsule. On Earth, glaciers preserve records of ancient climates. Tiny bubbles trapped within ice reveal atmospheric conditions from long ago. Dust layers document environmental changes. Chemical signatures preserve histories stretching back hundreds of thousands of years. Martian glaciers may perform a similar function. Hidden within the ice could be records of climate shifts spanning millions of years, a frozen archive waiting to be read, and perhaps something else. Life. Again, Mars forces us back toward the same question. The doorway into the Martian underworld. Mars is full of scars, craters, canyons, flood channels, ancient shorelines. But some of its most important secrets may not be on the surface at all. They may be underground, hidden from sunlight, hidden from radiation, hidden from every spacecraft that has ever crossed the planet's skies. And the only clues we have are holes, dark holes, perfectly black openings scattered across the Martian landscape. Openings so dark that even orbiting cameras cannot see their bottoms. Places where the surface suddenly gives way to nothingness. These are the lava tube skylights of Mars, and they may be the most valuable locations on the entire planet. At first glance, they don't look impressive. Many appear as simple circular pits, dark shadows surrounded by dusty terrain, easy to overlook, easy to dismiss. Yet those shadows may conceal enormous underground worlds. Entire cave systems stretching for kilometers beneath the surface. Natural shelters created billions of years ago. Places untouched by weather, untouched by erosion, untouched by almost everything. To understand why these caves exist, you must travel back to a time when Mars was volcanically active, a time when molten rock flowed across vast regions of the planet. Lava rivers spread over the landscape. As the outer surface cooled, a hardened crust formed. Beneath that crust, molten lava continued flowing. Eventually, the eruption ended. The lava drained away. A hollow tunnel remained. A lava tube. The same process occurs on Earth. Hawaii contains lava tubes. Iceland contains lava tubes. The Canary Islands contain lava tubes. Mars appears to contain them as well. But there is a crucial difference. Mars does everything on a larger scale. Lower gravity allows structures to grow much larger before collapsing. Scientists believe some Martian lava tubes may be gigantic, far larger than anything found on Earth. Some estimates suggest tunnels wide enough to contain entire city blocks, perhaps even larger. Imagine standing inside a cavern so vast that skyscrapers could fit beneath its ceiling. That possibility is no longer science fiction. It is a serious scientific hypothesis, and the evidence continues to grow. The first clues emerged when orbiters began photographing strange pits on volcanic terrain. Unlike impact craters, these pits lacked raised rims. Many appeared unusually circular. Most importantly, some displayed overhanging edges, features consistent with collapsed cave ceilings. In other words, the surface had broken open, revealing the void beneath. A skylight, a natural window into an underground world. One of the most famous examples lies near Mons, one of the giant volcanoes of the Tharsis region. Several enormous pits dot the slopes. Some measure over 100 meters across. Others descend into darkness so complete that sunlight never reaches the bottom. Even high-resolution cameras struggle to reveal what lies below. The darkness swallows everything. That mystery immediately attracted attention because underground Mars is very different from surface Mars. The surface is hostile. Radiation constantly bombards it. The atmosphere provides almost no protection. Temperatures can plunge below minus 100 degrees Celsius. Dust storms sweep across entire continents. Micrometeorites strike the ground. The environment is relentless. Underground conditions change dramatically. Rock blocks radiation. Temperatures become more stable. Dust storms lose their power. The environment becomes far more survivable. In many ways, Underground Mars may be closer to a habitable environment than the surface itself. That realization has transformed how scientists think about future exploration. For decades, most visions of Martian settlements focused on surface habitats, domes, bases, pressurized buildings. Today, many researchers see caves as a more attractive option. Why build protection when nature has already provided it? A lava tube could become an instant shelter, a ready-made habitat, a fortress against the hostile planet above. Future astronauts may someday live inside these caves, work inside these caves, raise crops inside these caves. Entire communities could potentially develop beneath the Martian surface. The idea sounds futuristic, yet it may ultimately prove practical. But human settlements are only part of the story. The scientific potential may be even greater because caves preserve things. On Earth, caves act as natural archives. They protect fossils, ancient sediments, environmental records, archaeological remains, delicate structures that would otherwise be destroyed. Martian caves may perform the same function, perhaps even better. Some cave systems may have remained sealed and protected for billions of years. If evidence of ancient life exists anywhere on Mars, underground environments may be among the best places to find it. Life prefers protection, especially microbial life. Deep underground, small pockets of water may have persisted long after surface conditions became lethal. Chemical reactions could have continued. Microorganisms could have survived, perhaps not indefinitely, perhaps not until the present day, but longer than anywhere else on the planet. The caves therefore become more than geological curiosities. They become possible biological sanctuaries, and that possibility is extraordinary. Imagine descending into one of these skylights. The sunlight fades behind you. The temperature stabilizes. The silence deepens. Your helmet lights illuminate walls untouched for billions of years. No human has ever stood there. No living creature known to science has ever stood there. You are entering a world completely separate from human history, a world hidden beneath another planet. The psychological impact would be immense, because these caves represent something rare, true exploration. Not exploration in the metaphorical sense, real exploration. Going somewhere nobody has ever been, seeing something no human eyes have ever witnessed. Experiences like that are becoming increasingly uncommon on Earth. Mars still offers them. The lava tubes remind us that Mars remains largely unknown. We have mapped portions of its surface, we have landed rovers, we have studied rocks, yet the overwhelming majority of the planet remains unexplored, especially below ground. Entire underground landscapes may exist beyond our current understanding. Vast chambers, complex tunnel systems, ancient geological records, perhaps even evidence of past life, all hidden in darkness, waiting. And that brings us to the deeper truth behind every place we visited in this journey. The canyon larger than nations, the volcano taller than imagination, the frozen glaciers, the lost ocean, the ancient lake, the labyrinth, the flood channels, the caves. Each location tells the same story. Mars is not a dead world. It is a world that remembers. Every cliff remembers water. Every crater remembers impacts. Every glacier remembers climate change. Every cave remembers fire. The planet is a vast archive preserving billions of years of history. And when you step back and look at the whole picture, something remarkable emerges. Mars is not merely a destination, it is a warning, a lesson written across an entire planet. A world that may once have possessed rivers, lakes, oceans, and potentially habitable environments. A world that changed, a world that lost much of what made it hospitable, a world that became something colder, something harsher, something lonelier. And perhaps that is why Mars fascinates us so deeply. Because when we look at Mars, we are not simply looking outward into space, we are looking at a possible version of planetary fate, a reminder that worlds are fragile, that environments change,